This is a nail gun, and when controlled by a hairless ape, it is capable of quickly putting nails in very precise locations. But I am an easily distracted individual, which also makes me a very precise location. Now, according to the Anti-Fun Police, I just joined an exclusive club that accepts 37,000 souls a year. So in the name of safety, I decided to turn my nail gun into a remote-controlled rover that can nail boards and nail threats without me ever endangering my hands. Now, you can't just fire a nailer willy-nilly, because the tip needs to be pulled back for the trigger to engage, which is an incredibly dangerous feature because it almost puts my finger in harm's way. So to avoid this design flaw, I did a little surgery by decompressing the patient and then giving it the cold shoulder, and now I felt much safer operating my nailer. And after getting some practice in for the next time my neighbor's kid has a birthday party, I had some trouble getting the nail gun to be controlled remotely. But that's because I was essentially talking to a wall, since the nailer didn't have ears, but thankfully I knew just the trick. This is a robotic ear, and after supplying it with some robo-blood and a sword's arch nemesis taped to a linear actuator's arch nemesis, I could now create modern art from the comfort of my chair, and I think I'll call this one Bold and Brash. The idea here is that the servo can actuate the trigger, but this servo would rather die than do that. So like a true American, I replaced the 9 with a 45, and sure enough, that one had more than enough force. I then did some 3D modeling on these new business-deductible monitors, and now that I had a proper test set up, I firmly grasped the nail gun, and then it was time for a remote fire test.
3, 2, 1. That is terrifying.
Alright, I could now fire remotely, and the next step was to do the locomotion, which everybody is doing now, by the way. But to locomote the nailer, I got a sweet set of these puppies, which typically power rocket skates and are expensive, so you don't want to drop them. These should have more than enough power to drive the rover, but my 9-volt battery wouldn't work since some idiot added an extra connector to the motor. So after some research, I found out these motors require a special battery and something called an ESC, and this nifty quad-screen browsing experience is from something called an Opera, which happens to be today's sponsor. Opera is a free internet browser that makes you feel like you're living in the future promised to us in the 50s, and I really wish I could browse the web, but the customizable dynamic wallpaper has me captured like a cow in a tractor beam.
Moo.
Opera operates at a higher plane of understanding, like having tab islands so I can keep my 300 tabs of every single screw dimension on McMaster Car separate from my vacation planning or my extensive research into Bigfoot, and I can easily rename and color coordinate these tab islands. It also has split screen mode for improved workflow, and the split screen is so advanced that the split screen can split screen into however format I want, which means I can now read product specs side by side to make sure everything works together and is actually incredibly useful. Speaking of usefulness, I don't even have to watch this horrendous video now to know the content in it because I can just command Opera AI to quickly summarize all the useful information in a video and save me from 10 minutes of the worst engineering the world has ever seen. And for those who only have a single monitor, you can now have second monitor content play on a virtual second monitor with Opera's video pop-out feature, so you can really focus on the A-list material. So if you want to ameliorate your internet browsing experience, click the link in my description below to download Opera for free right this very second. Thanks to Opera for sponsoring this video. Now back to setting up this beefcake of a motor. I connected all of this electrical doohickery, put some tape on the motor shaft so I could tell if it was spinning, and then powered on the system and hoped for the best.
Whoa, 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 whoa.
It turns out initial throttle calibration is real and can hurt you, and unfortunately running away from my problems by just turning off the controller didn't work.
No!
Thankfully, a little arc welding never hurt nobody, and with the proper setup, the motor worked perfectly until I realized I had a major issue. Right now, my motor can only turn one way, which is fine if the front wheels can steer, but my plan is to turn the rover with tank steering, which means each motor drives one side of the vehicle, and I will need the motors to rotate backwards in order to turn according to these cheat codes. So I ordered these wishy-washy ESCs instead, but those will take a few days to get here, so in the meantime, I needed to make a frame for the rover to mount all this stuff to, and using my body as a size reference, I could see that my 3D printers would be too small for this job, and this steel filament probably wouldn't work in them anyway. Luckily, I got this welder from the Big 16 himself, and even though it's usually used on USSR jets, I should be able to take this steel and make it into a simple frame. I actually set up this welder and made the welding card it sits on as part of my Patreon content, so if you're interested, please go check that out to support the channel. After doing some extremely rapid bumping and grinding, my frame was now complete, minus the whole welding thing. This chart of popular battleship moves is actually directions for optimal knob location based on material thickness. And once I got my steel squared up, the first thing I did was a tack weld, which we in the industry use to make sure everything stays in place during initial workpiece layout. From there I welded up the frame exterior, and my welds were kinda icky, but 700 hours with the steel brush later I got them all ground down and purty looking. I then did a mock-up of where the wheels would go so I could find a good location for this cross member to hold the air tank. And after attaching said member, I then needed to mount the tank and then install the tank by drilling at these locations. Unfortunately, my drill press came down with a serious case of the runs, so I had to drill the holes out like a peasant, but at least I was a precise peasant.
Oh, heck yeah.
The tank didn't seem like it was going anywhere, and the next step was to mount the wheels so that it could go anywhere. Each wheel was going to be chain driven in this mechanical love triangle, but I couldn't just mount a sprocket to it because this bearing would allow the wheel to spin freely. So to spin the wheel restrictedly, I thought I could just take the bearing off with these 4 bolts, but apparently that's what keeps the entire wheel together. So I employed the caveman conflict resolution technique until the bearing had had enough, and since the sprocket didn't quite fit inside the wheel, I made this hammer fit adapter, made a custom drive shaft that also enjoyed being hammered, and then installed the sprocket to create a perfectly balanced drivable wheel. While you were distracted by the tire, I went ahead and installed the motors and these wheel bearing mounts. And before I mounted the nail gun on the front, I tested to make sure the motor still worked by driving this chain. I then put the wheels in their respective homes, and they seemed to like rolling, which was great news.
Sweet.
Next up was installing the chain, and if you've been feeling a little cold, it's because I keep that ice on me at all times, and it just so happened to fit the rover perfectly, so now it was time for a little test drive. I was barely giving it any power, and it could even do a small agility course, but I was still waiting on those reversible ESCs, so in the meantime, I measured where to mount the nail gun using my tape measure that I definitely washed since the last video. I then printed this head mount bracket and melted some metal together, which I attached to the bow of the rover, and for once everything seemed to fit together first try.
Oh, that is awesome.
With the nailer at optimal wood hitting height, I now needed to be able to turn it remotely, and to do that I just used these leftover parts that have been clogging up my toolbox, which were somehow a perfect fit. I did a quick test to make sure the servo was strong enough to move the head. And since everything was going so smoothly up to this point, it was now time for everything to fall apart. That is the sound of dreams dying, but more importantly, it means the added weight of the nail gun was too hot baby, too hot to handle. And that little test put the alignment out of whack, and I accidentally disemboweled my wheel hub trying to fix it. Now, the motors drive the wheels with the same size sprockets, but according to my research, if I make the wheel gear bigger and with more pearly whites, I'll get 2, which is just math. So I printed this larger gear with the PETG suffering from a genetic disorder, and the way I set up my printer to be able to print this would lead one to believe I also suffer from a genetic disorder. With the new gears installed, the rover was able to drive both ways with only a little bit of motor skippage.
Whoa.
But I still didn't have steering, and that meant I needed to spend some Uno on Uno time with the Uno. I need the Arduino to take the signals from the receiver and tell each motor to rotate the correct way so that I can turn, and I'll give you the abridged version of how that programming went.
That's crazy. Don't do that.
Eventually, I trusted it enough to put it on the ground, and it immediately abused my trust by executing the worst left-hand turn in history, somehow undoing the chain and blowing apart a gear. So I put some tape on the wheels to help it turn with less resistance, gave the gear a kiss on its boo-boo, and then it finally still didn't work.
Whoa.
I was just about to call it quits, but I never picked up the phone, and after hours of troubleshooting, it finally did this. turn left. Okay. Now shoot that over there. Whoa, whoa, whoa. And fire. The stupid thing actually worked, so I set up 2 balloons for a better turret test and got skill diffed by a latex sphere.
Firing in 3, 2, 1. There we go, finally, good lord.
But now it was time to try an everyday scenario. I've got 2 boards to nail together, but there's also an evil individual with a knife that needs to be taken care of, and since I'm really comfy in my chair, I'll dispatch my nail gun rover to take care of both birds with a couple sharp and skinny stones.
Well. Okay, we're just gonna... Fire right there.
I'd say that went pretty well, but the nail didn't stick the boards together, so I made it a little easier for the bot and then made sure those pieces weren't coming apart.
Good job. That's a good board.
So far it was working flawlessly, but the real test was this outdoor obstacle course. It first must drive over the pallet of instant wheel breakage, slalom through these posts, pop these fraternal twins at a distance, and then score a bullseye, all within 1 minute.
3, 2, 1, go. Yeah, I'm done.